Here's the list of parts, both electronic and otherwise. The parts on the top, the electronic parts, you can get from Amazon or DigiKey or your favorite electronics parts supplier. Likewise, you can get the hardware and the miscellaneous items from your favorite supplier of those types of parts. Now here's a pinout of the development board, and you can get an ESP32 that does not have this exact pinout. So in that case, I provided a wiring diagram that you'll see in a little while, and it has the references to the appropriate GPIO pins. All you need to do is use those references in the wiring of the unit, rather than the actual wiring diagram, which is specific to the ESP32 version. On either side of the control box, we have a stomp pad. And essentially what that is a piece of wood which is 11 inches high and 4.5 inches wide that holds the switch and the flapper over it that you stomp on to create the sound. However, you just have to do a little bit of modification here. So what I'm going to do is make some drawings here so that you can see. We're going to go down 1 inch and down 7 inches, and we're going to go over 1 inch. Now this part is going to be cut out, and in the remaining section we're going to put the holes for the switch holder and the switch. From the non-cut end, we're going to go down 3.5 and over 2 inches. That's where we're going to use 2 Forstner bits or something similar to drill 2 holes. The first hole is going to be with a 5/8 inch Forstner bit, and the second hole is going to be with a 1 3/8 inch Forstner bit. So let me show you what that looks like when that's all been done. Here are 2 finished stomp pads. This is the one I laid out, and this is its mirror image. So we have one on the left and one on the right. Now, here are the 2 holes that I talked about being drilled with the Forstner bits. This hole is 5/8, and this hole is 1 3/8. And the reason that we need these 2 holes is we need to put in these switch holders, and they need to be roughly flush with the top. So I drilled the 5/8 inch diameter hole all the way through, but I drilled the 1 3/8 only down a 1/2 inch, leaving a 1/4 inch shelf there. And this switch holder that we saw before can go right in like that, and then we can mount it with some small machine screws, as we did right here. 2 machine screws and nuts. So when we put this in like this, and we can access not only the switch but the wiring to those 3 terminals, which will come through here. Now when we stomp down, we'll trigger that switch. Now here's one of the stomp flappers again, and you notice when this was printed, this piece is very thin and it forms a bit of a hinge. So when I put this on here like that, I think you can hear that. It triggers and then it comes back up. And this is our stomp pad. Now that the stomp pads are more or less done, except for the wiring, we can start building the chassis. And the chassis, of course, has 6 sides, 2 sides, a front, back, top, and bottom. So we're going to start with the 2 sides. And you notice these sides are essentially the same, but they're symmetrical so that we can use one here and one here, and it's the same side. Now, the sides are going to be attached over here. This is the front, and this will be flush with this cutout. And we want the bottom to be flush with the bottom. Okay, that looks pretty good. It's flush on either side. Let me hold that down. And here is one of the holes that I'm going to put a screw in, and here's one of the other holes that I'm going to put a screw in. And here's our other screw. Okay, that side's done. Now we can do the same thing on this side. Okay. So now we have the two sides put on. We have to do one more thing. We have to drill a hole through here over to here. To do that, I'm going to use a 1/4-inch drill bit. And you see how it comes right through. Do the same thing right here. Right through. Now I've taken one of the switches and I've taped it down temporarily, and I'm going to solder 2 wires to 2 of the terminals. Let me start with the end one. And you notice that I position the switch so that the end of this is on this side here. And there we go. And with that done, all I have to do is take these wires and put them through the 2 bottom holes here. And then I'll take the wires and run them through the hole that I drilled. And now they can connect to the circuitry. And to make it nice and neat, I will take a 1/2-inch long sheet metal screw and put this cover on. And I will attach the flapper with 2 more of those same screws. And of course we want to position the flapper so that it is centered in between this smaller dimension. I'm going to position it about 4 3/4 up from the bottom. And now this stomp pad is done. And I'm going to do the same thing to the other stomp pad. We can proceed on to the chassis. We have the front, which is going to go here, the rear, which is going to go here, and the top, which is going to go here. And we're going to hold off on putting the bottom on because we have to do the wiring first. So let me do this. Okay, and now we can put the top on. And the space for the OLED display goes on top, and we just screw these all together with 6 more screws. And what we have is our assembly with the wires coming in on the sides. Now what's left to do for the build is to populate the front panel, the top here, and also put in all the other pieces that have to go together before we can do the programming of the ESP32 and everything else. This lettering here was 3D printed on, but it's the same color as the background, so it's not that prominent. So what I'm going to do is I'm going to paint this to make it pop out. And all I'm using is a normal kitchen sponge that I cut a piece out. You notice I have a little bit of paint on there. I'm going to put some more on. And all I have to do is just dab this on, just like that, and it'll only go on the top. Just be careful. And there you go. That looks much better. Before we get into the internal wiring, I want to go through a few things I didn't tell you about before. I'm going to use this top that I had a little problem with and had to redo. When we completed the construction before, we hadn't added in the switches. So let me go through that. As you notice right here, here's the switch holder, and you notice there is a screw, a nut under the switch holder, and a nut on top of the switch holder. That does two things. It keeps the switch holder in place, but it also positions the switch holder a little bit away from the top. And that allows the switch holder to be relatively flush to the top. I've used number 440 machine screws, about a ½ inch long, and 440 nuts. Here is the circuit board we're going to be working on, and this circuit board is held in place not by 440 screws but by 632 screws. They need to be a little larger to maintain stability for the circuit board. And just like the other one, I have the 632 screw, which is about 3/4 inch long, and two 632 nuts on each one of these screws. You'll also notice that the 632 screws, which hold the board, will be under the flapper. So those screws have to be put into the top first before the flapper is installed. I'm just completing putting the last flapper on over the switch, over the screws that hold the board. Okay, there it is. And now we can proceed to look inside and do that wiring. Here is a diagram of the wiring, and all of the components are in the relative position as they are in the device. So you see the circuit board is in the middle, the display is above it, the stomp switches are on either end, and the select switches are in between. The output jack and the output volume control are up on top. If you look at the circuit board, you will see that there are columns of connections and there are rows, just like on a solderless breadboard. You'll notice these columns are numbered, and they're the same as you see in the wiring diagram. So it's an easy matter just to bring the wires to the proper position on the ESP32 by referring to those column numbers. And also I should point out that in soldering the ESP32, you only have to solder the leads that wires are attached to. Now let's look in the chassis and see how the wiring is done. Just like the wiring diagram, here's the circuit board, here's the ESP32, here's the output jack and the output volume control. These are the right and left select switches. And of course, the wires from the stomp switches are coming in here. And you'll notice that all the wiring mirrors the wiring diagram. So it's just a simple matter of following the wiring diagram and interconnecting all of these devices. Earlier on, I had said that I had changed the front panel, and this is that new front panel. It just has an out for the jack and the control and the USB connector. Okay, the bottom is on the chassis. We can turn this over and connect it up and give it an initial test. We take an audio cable from an amplifier and put it in here. And then we take a USB cable and plug it in here. And that's what happens when you first turn it on. You'll hear the first sound in the list, and in this case it's a kick. So here's our kick. And we can adjust it. And you might ask, what the heck is that? Well, that's just a sample that I put in here to show that you can put anything in here and use it. That, in fact, was my grandson, who I recorded saying Timmy, of course, from South Park, which we both love. Well, it looks like everything's working fine. So we can proceed on to talk about the software and the programming that's necessary to get any specific sample you want in here to work. I want to talk to you about a few differences in the final configuration. First of all, we had these switch holders, and I've replaced them with a redesigned one. It has the same utility, it has the same mounting hole dimensions and spacing, but it fits better inside the chassis. And speaking of the chassis, let me show you what the chassis now looks like. There aren't too many differences. The real difference here is the USB connector. It's now connected to a USB cable that goes directly through a strain relief and out the back. And I want to show you how that strain relief works. I'm going to show you how this standoff works. I'll take it apart. And what we have is three parts. We have two identical halves that, when they're put together, allow the cable to go through. And we have a wedge. This is actually wedge shape, and it secures the standoff to the front cover. So let me show you how to do that. You take one end with the smaller end towards the front cover. You put the cable in there. You take the other end, put it in, line them up, and then push it through the hole here. And then you turn it so that the two pieces are on top of each other. And now you use the wedge to secure it down. And push it all the way over, and you have a sturdy connection that will not come out. And let's take one last look at the front panel. I painted the two labels just like I did on the top. We have the volume control here with a 3D printed knob. We have the output 1/4 inch jack, and we have, of course, the cable coming through with the USB connector. So when you're programming or reprogramming the connector, you have this end, which is a USB-A, and you can plug it into your computer and make that connection. Now, when you're going to play, you take any standard 5-volt cube that would use to charge your phone, and you just put it in, plug it in, and you're ready to go. For those of you who are not familiar with the process of microcontrollers, let me walk you through it. First thing you have to do is load the Arduino IDE. And here it is on this page. Click on that. And then download the latest release, which is version 2.3.6 right now. And load it up. And here it is. Now, the first thing you have to do is select the board, and that board is the microcontroller. So you see we have an option for ESP32. We'll pick that and pick the WROOM module, which is the one we're using. Now, the problem here is that there's no port shown because I'm doing this demonstration on a laptop. So I have to load a piece of software called the CP210X bridge that simulates a serial port so I can work with the Arduino IDE. Here you see I selected it and now it's loading. And when I go to install it, it says you have to extract the files first, so I did that. And now I can select that one there, go through the process and load it up. I have to restart the computer so that it will take effect. Now it's taken effect, and let's take a look. I've installed the actual Stomp8 program, and I'm compiling the sketch just to see if everything is okay. And it looks like it is. Now I'm going to compile it and try to upload it to the Stomp8 hardware. Oh, it says there's an upload error. What I forgot to mention is that you have to plug in the hardware first before the serial port will appear. You notice now it's there. Since I re-clicked, it's there, and it is COM3. So now let's go and recompile and upload the software. It was successful. Now this is going to take a lot longer than here because I've sped it all up. But it's done uploading and we're ready to start using the Stomp8. There are 4 steps to reprogramming a sample in your Stomp8. And while I'm giving you instructions, I'm going to actually go through it and show you how relatively easy it is. In step 1, we're going to load Audacity and bring the wave file into it. So here's Audacity, and I'm going to load from the Lin drum samples and take the closed hi-hat. Now let me see how this sounds. Sounds pretty good. Let me see if I can make the sample a little shorter so it can be more responsive. That sounds just as good. So I think I'll keep it there. Now we're going to export the sample, and we're going to use these settings. Now we're going to extract that raw file PCM data into a hex file. And this is HXD, and we're going to load that raw data in there, and we're going to copy it. And then now we're going to format those values we just copied in Notepad. Now I'm going to paste them into Notepad. I'm going to put a space in the very front and go to Replace. And you notice I have the things I need to have there already, and I'm going to replace all. I'm going to go to the beginning of the file, take away the comma, put in the bracket, go to the end of the file, put in the bracket and a semicolon. And that's really all there is to formatting. And now fourth, I'm going to embed the sample. And this looks like a big one, but it really isn't. Here's the program. I'm clicking 3 times on that line so I can delete it. Then I'm taking the one above it, and I'm just using the beginning part of it, copying it, opening up a space, and pasting it. And then I'm changing the number to represent the actual sample that I'm reprogramming. I'm copying the formatted data and pasting it in. And And as the last thing, I'm going to change the actual name that will appear on the Stomp display. To make sure everything went right, I'm going to compile the sketch. And it compiled fine, so I'm going to download it. And that downloaded fine.